Hello everyone. So in the previous video we discussed about the causality, and now in this video we will discuss about another basic system properties, that is stability of a system. So in this we will discuss about what is meant to be a stable system and what is meant to be an unstable system. So in very basic manner we can say that stable system is a system in which if we apply small input, it will lead to a output which does not diverge. So output will not diverge. So this is a stable system. So I'll give you one basic example, a real life example, to understand the terms what is meant to be stable and unstable. So suppose we have a system in which a pendulum is hanging from a wall, and this is your vertical line, and if we apply a force which is equivalent to xt to this pendulum, so due to gravity and friction it will get back to its position, which is the vertical position, after oscillating few times. So ultimately it will come back to its position, which is this vertical line. So this is meant to be a stable system. Now assume another kind of system, that is inverted pendulum, we can say that. So this is your vertical line, and an inverted pendulum, the pendulum is at the vertical position, and now if we apply a force of xt to this pendulum, the pendulum will diverge due to gravity, and this makes the system unstable. So as you can see, our first system was stable, but the second system was unstable. So the basic definition is that for a small input, the output will not diverge. Now I'll give you some basic formal definition with respect to our signal system perspective. So the definition for a stable system is that, so stable system is defined as a system is said to be stable if bounded input will lead to bounded output. And here the word bounded refers to a magnitude which is not unbounded. So the magnitude should be a finite value. So it is not that it is infinite or increasing with time. So it should be bounded. So let's take some example to understand this concept better. So first we will take an example of a system whose relationship is given by, so we will discuss about example 1, in which we will take a system whose relationship is given by xt is equals to t into xt. So here you can see that if we put a input xt is equals to 1, then our output will be yt is equals to t, and the output yt will increase as the t will increase. So if t is increasing, implies your yt will also increase. So this system is unstable. Now we'll again take a basic example. So example 2, we'll take a system with yt is equals to e raised to the power xt. So to solve this, we can either have some cases or take some examples of xt which will make it unbounded, or we can use a traditional approach that will first assume that our xt is bounded. So there is some b value which is showing that it's a finite value, and the mod xt is less than that b value. That implies that xt will lie between minus b and b. So from that our system will be, so yt will lie between e raised to the power minus b to e raised to the power b, and as we know that b is bounded, so e raised to the power b and e raised to the power minus b will be some bounded values. So if the input we are taking as a bounded, then our output is also getting bounded between two values, that e raised to the power minus b and e raised to the power b. So this implies that this system is stable. So in this manner we can assume that how a stable system and unstable system is defined. And we have to further take into account when we discuss different type of systems in further lectures, then we will check the stability of the system and how it is important to define a system. So thank you.